Our topic is congruent triangles. And today is the 3rd of November. All right. Tomorrow there's a whole lot of sports going on for the Dows. So if you're able to travel to the Eugene Springfield area, you could watch both cross country and volleyball. If you're not able to travel, the boys soccer play at home tomorrow over at Wetumpka at 2:30. Is that right? All right. Show up to that if you can't travel to Eugene or Springfield. So, all right. So, congruent triangles are triangles with the same shape and size. Same shape and size. They are identical in terms of their angle measurements and their side lengths. So that means that their angles and sides are congruent. Every side matches with a side in both triangles. Every angle matches with an angle in each triangle as well. So here is a congruence statement or a congruency statement that we can write for these two triangles. And I'm going to talk about some things real quick as well, because there's actually a really simple way without using the actual diagram to figure out which parts are the same. Because sometimes it can be a little bit tricky based on how the triangles are oriented. So I'll show you what that looks like in just a second. So the congruency statement here says that triangle ABC is congruent to triangle DEF. I want to make sure that everybody understands this and hears this right now. Everybody listen. There is a specific order that you must write the letters in when you write a congruence statement. It doesn't necessarily need to be alphabetical either. It's a little bit challenging at times. However, you will always have a way of figuring it out, and I'll talk about that in just a second. But if you look here in the actual writing of this congruency statement, angle A on this triangle here is the first letter, right? Angle D is the first letter over here. What do you notice about the markings for angle A and angle D? They're different letters, but what do you notice about the marking on each angle for A and D? It's the same, yeah. So it is very important that the angles that are the same between the two match up with the order over here. So like if you look at the diagram, B matches up with E because those have the double markings, and then C matches up with F because those have the triple markings. Everybody see that? Not only that, if you look at A to B right here, look over here at length AB. So like if you look at the first two letters here, that's talking about this length AB. If you look at the first two letters over here, DE, from D to E, what do you notice about the marking on the side? It's the same. There's one mark between A and B, and over here, there's one mark between D and E. And then if you look at B and C right here, from B to C, there are two markings, and over here from E to F, there are two markings. So those sides, we call them corresponding. The parts correspond from one to the other. And then from A to C right here, A to C has three markings, and from D to F down here has three markings as well. So as long as you line up the parts that are the same, you can write these letters in any order. For example, if I were to write triangle BAC, we would have to change the order of the letters over here. Yeah, write this down. If we were to change the orders of the letters here, we would have to switch up the letters on the other triangle. So if you go back to the original statement, the middle letter on the first triangle matches with the middle letter on the second triangle. So if we start with B on our second statement, what do we have to start with here? E. If you look at these two triangle statements, B is in the middle of the first one, E is in the middle as well over here. So if we start with B here, we have to start with E over here. A was the first one up here. D was the first one on the second triangle. Now it's in the middle, so D has to be in the middle here. C was the third letter. F will stay the third letter over here. So you have to match up the parts that are the same between the two when you write your congruent statement. Otherwise, you're not talking about the parts that are the same between the two triangles. So you got to be really careful about that. So this says right here, a valid congruency statement. That's exactly what I've been talking about. Must match all corresponding angles and sides. So when you write the statement, the parts that match from one triangle to the other need to be in the same position when you write those statements. All right, now here's our next thing that we're going to be learning, and this is what's known as CPCTC. And it's something that we're going to be able to use for proofs, because we are going to do some proofs, not today, but next week we're going to take a look at some proofs. And we will use this from time to time. And CPCTC stands for, here we go, corresponding. Corresponding is the first word. And then the second word is parts. Corresponding parts. So like on this first triangle, A corresponds to D, B corresponds to E. So corresponding parts of congruent what do you think the T stands for? Triangles, yeah. Corresponding parts of congruent triangles are congruent, yeah, because if you look up here, if you look at the corresponding parts, A corresponds to D, those are congruent. Corresponding parts of congruent triangles are themselves congruent. So basically, if you have two things that are the same size, every part in those two things are going to be the same size. Makes sense, right? Let's say you have, well, here we go. I'll just use these calculators as an example. These two calculators are congruent, right? Same shape and size. So the top right corner of this calculator matches with the top right corner of that one. So the parts are the same size within each of these. All the screws in the back are the same size between them. If I took the screws out of this one and I put them in that one, it would work because they're the same size. So that's what we're dealing with this statement. That last word, by the way, congruent. Corresponding parts of congruent triangles are congruent. Thank you. Here's the notes for today. All right. You're welcome. So next thing we're going to do is we are going to list congruent parts between the two triangles that are congruent. So it says right here that triangle JKL is congruent to triangle PQR. Now, if you want to, I'm just going to go and grab some colors. You can use colors to figure these out. So if you want to use a highlighter, and just say, all right, here's J. J corresponds to P on the other triangle. For the middle ones, K corresponds to Q. And the ones on the end, L corresponds to R. If you want to do something like that to help yourselves out in terms of what parts would correspond and which ones maybe won't, that can be helpful. So each individual letter in each triangle is its own angle. So for example, in terms of angles, we would start with yellow to yellow. Angle J is congruent to angle P. And then we're going to match up pink with pink. Angle K is congruent to angle Q. And then green to green. Angle L is congruent to angle R. Any questions about that? So the literal order is how you can match up those angles. Now, in terms of the sides, you just go from one letter to the next. So for example, from J to K, that would be yellow to pink. So we would say JK, segment JK, is congruent to what? Segment PQ, yeah, yellow to pink, PQ. Let's go pink to green. Segment KL is congruent to segment QR. Good. And then there's a third length on each one. That would be yellow to green. So that would be segment JL is congruent to segment PR. Exactly. So we don't even need to see what the triangles look like to match up the corresponding parts. In fact, I think it's easier to not even look at the triangles to figure out which parts correspond. If you have a congruent statement, personally, I find it easier just to use the statement to find out what parts match up. Because as you'll see, once we get to number 3, it makes it a little bit more challenging if you have to look at the triangles to figure it out. But I want you to do number 2 first on your own. Oh yeah, we need to actually rewrite this. Write another valid congruency statement. So basically, mix up the letters, but still make it correct. No, for down here. Write another valid congruency statement for that. So change the order of the letters on the first one. So somebody give me these 3 letters in a different order. KLJ. All right. So triangle KLJ is congruent to triangle. So the K is pink. Match it up with pink. Which one goes first on the second one? Q. L is green. So next one would be R. QRP. There you go. Triangle QRP. So it doesn't actually matter. Like, it doesn't matter if it's alphabetical or anything like that. As long as you match up the parts that are congruent, you're fine. All right. Do number 2 on your own. Problem number 2 on your own. All right, so those are the parts that are congruent right there. Angle W is congruent to angle E. Angle X is congruent to angle F, and angle Y is congruent to angle G. Those are the angles. For the side lengths, we should have WX is congruent to EF, XY is congruent to FG, and WY is congruent to EG. For the one at the bottom, there's a lot of correct answers. I'm just going to come up with one on my own. If yours is different than mine, but it still works, that's great. So I'm going to say triangle, I'm going to start with the other one, FGE. You can start with the second one first. It doesn't really matter. Rob? Yes, it does. Because if it matters what, if it matters with the angles that match up, it matters which letters come first and second with the statements of the sides as well. Yeah. So I'm going to go with triangle FGE, and then that would be congruent to triangle XYW. So I completely switched it around and mixed up the letters, but still means the same thing. All right, let's move on. Any questions before we continue? That was number 2. Here we go. Number 3. This is what I was saying a moment ago. It can be a lot more challenging to figure out which parts match up with what by actually looking at the diagram. I find it more difficult to look at the diagram. I would rather just look here because then we know which parts match up. So if we wanted to, we could do the same thing we just did on number 1. So like K matches with A. So that means that K here matches with A there. With the middle letters, P matches up with Y. So P goes with Y. And then the final two would be M and C. So M corresponds to C. So M and C are also congruent. Looking at those two triangles, it would probably be more challenging to figure that out than actually looking at the congruent statement. I prefer the congruent statement for that. So what I'm going to do next is I'm just going to put congruent markings on each angle. I'm going to do single markings with K and A. Bless you. I'm going to do double markings with Y and P, and I'll do triple markings with M and C. So I'm just going to mark them on the diagram. Because now I know which ones correspond, I know what angles are congruent to which other angles. We can do the same thing as well with the side length. So I'm going to do a single congruent marking between M and P, which means I'm going to do a single congruent marking between C and Y. Green and pink match up for the side lengths. Green and pink match up for the side lengths. I'm going to go double markings with K between K and P. That would be pink and yellow. So over here between pink and yellow, double marking between A and Y. The third sides, yellow and green. I'm going to do triple markings between yellow and green. Same thing on the other one.
How do you know how much to do?
Like the amount of lines. I just start with 1 and then go to 2 and go to 3. So like we can't do 1 here and 1 here, because that would mean that this side is the same as that one, but we don't know that. So we have to, anytime you change the corresponding congruence parts of it, you have to add another line or another curve to say that these two are the same as each other, but they're not the same as the other angles. That's why we do other, like, more lines with that. So like this angle is not the same as that one. This one's the same as that one. And the only way we can actually know that is if we add more lines just to differentiate between what's congruent and what's probably not congruent. All right. So part A, segment KM is congruent to what?
Yay.
AC, yeah. Make sure you put A first, AC. It does matter. And again, I would not really look at the diagram here. I would just go back to the congruent statement here. If you look at KM, that would be yellow-green. So use yellow-green from the other one. CY. CY would be green-pink. So that would be MP, exactly. PK, that is pink-yellow. So YA, yeah. PK would be the same as YA. All right, angle-wise. Y corresponds to what? P, so angle P. Angle K corresponds to angle A. All right, ooh, here's another one. Here's angle ACY. So ACY would be KMP. You got it. And it's angle. We're not dealing with triangles yet, but angle KMP. Good. So KMP. All right. Now we're talking about triangle congruence.
Wait.
CYA. Triangle CYA. And then PKM. Nice. Cool. There you go. If the colors help, use colors. If you don't need the colors, don't use the colors. It's up to you. I like showing that initially because it can certainly help tell the difference between what we're looking at. Any questions before we continue on the back? So basically today is all just about matching parts. There's not a whole lot of math that needs to be done on the back, just because we're just matching up lengths here. So let's see, BN. So if you look up here, from B to N matches with S to W. So what's the length between S and W on the first triangle? 9 centimeters, exactly. So we're actually writing in the actual length. So don't write SW over here, write the length of SW, which is 9 centimeters. Yeah, so BN, so from B to N on the second triangle matches from S to W on the first one. And since SW is 9 centimeters, so is BN. Let's see, from T to W would be from F to N. So what's the distance between T and W if it's the same as the distance between F and N? 14 centimeters, good. From B to F is the same as from S to T, 17 centimeters. Nice. Measure of angle W matches with the measure of angle N, 82 degrees. Measure of angle B matches with the measure of angle S, 67 degrees. How many degrees is angle F? 31. Good. Why? Why do we know that? Yeah. You got it. Because the three angles of a triangle add up to what? 180. We've got two of them. So take those away from 180. And you get 31 degrees. Nice. So once you actually learn how to match up the parts, these are ones, you know, not too bad. Pretty quick, actually. All right, what type of triangles do we have here on number 5? They are congruent to each other, but specifically they're each what? They're isosceles, yeah. Because if GHJ is isosceles, so is XYZ, even though it doesn't have the markings, because they're both congruent triangles. So that means we can put congruent markings on the parts of the other triangle that correspond to the parts of the first one. All right, so GJ matches with XZ. So how long is that? 18 feet, good. XY matches with GH, 27 feet. ZY matches with JH, 27 feet, because it's isosceles. Good. Angle-wise, H matches with Y, 38 degrees. Angle Z and angle J would have to be congruent to each other, because if we're talking about isosceles triangles, not only are two sides the same, so are two angles. 71. They are each 71. Good. Why? Yep. Good. If you take away 38 from 180, that means that those two angles have to add up to whatever's left over, which is 142 degrees. Since they're the same, just cut 142 in half. And they're each 71. So it's the same math that we did from lesson 4.3 when we were talking about isosceles and equilateral. So we're still using that math in some cases with these types of questions. All right. Little bit of algebra to wrap things up here. Numbers 6 through 9. Number 6. UVW, triangle UVW is congruent to triangle TSR. Find the values of X, Y, and Z. Are these side lengths or angle measurements? On number 6. Those are side lengths, okay. So we're not worried about angle measurements here, so nothing's going to add up to 180. But we do need to match up the right parts in order to write the correct equation. So UV is 3Z plus 14. No, it's not. It's 12x minus 7. That's UW. UV is 12x minus 7. So 12x minus 7 is equal to TS, because UV matches with TS. What's the length of TS? 53. That's one of our equations. I'm going to set up all the equations before I solve any of them. So the next one's VW right here, 57, is congruent to SR over here, which is 5y minus 33. So I'm going to write 5y minus 33 equals 57. That's our second equation that we're going to have to solve for. The last one, UW, down here at the bottom, 3z plus 14. is equal to TR, which is 50.
That's zero.
That is a Z. I usually put a line through my Z's just so they look a little bit less like a 2. All right, so now we're going to solve those. Two-step equations. Solving for x, what do we do first? Plus 7. All right, 53 plus 7 is 60. 12x equals 60. Now what? Divide. What does x equal? 5. Nice. X equals 5. All right. For y, what do we do? Add 33. All right. What's 57 plus 33? $90. All right. What's 90 divided by 5? 18. There you go. Y equals 18. All right, last one here. Subtract 14. What's 50 minus 14? 36. All right. So 3z equals 36. Divide by 3. Z equals 12. Now, in terms of the algebra that we do in this class, you might have noticed that most of the algebra equations that we do look really similar. Like even going back to unit 1, when we write equations in this class, they're not usually big, complicated equations. Like at most, they're like maybe 3 or 4 steps. These are only 2. So most of the time when you write an algebra equation in a geometry class, it's not going to be more than about 3 or 4 steps, if that. All right, let's try the next one. So again, find the values of x, y, and z, but this time are we dealing with side lengths or angles? We're dealing with angles. One of the main reasons we know that is because it's pointing directly to the corners, and we have the degree symbol, which means we're talking about angle measurements. So this time we're not going to match up 2 letters with each other. We're only going to match up 1 letter with each other. So let's see, P corresponds to C. So whatever P is, set it equal to C over here. So that'd be 4z minus 32 equals 36. That's one of our equations. So 4z minus 32 equals 36. That's one of our equations that we're going to write. H corresponds to N. So set those 2 equal to each other. 6x minus 29 equals 115. And the third equation, S matches with F. How many degrees is angle S? We can figure it out though.
150.
Take that away from 180, but as well as what? As well as the 36. So, wait. Wait, how many degrees is it? 29, yeah. That's 29 degrees. So then we could write 3y minus 1 equals 29. So 3y minus 1 equals 29. There you go. And then we're just going to solve each of those real quick. What's 32 plus 36? All right, so 4z equals 68. Divide by 4? 17. Z equals 17. Add 29 to 115. What is it? 144? Okay. 6x equals 144. X equals 24. Add 1 to 29. 3y equals 30. Divide by 3. Y equals 10. All right. Here we go. Last 2 problems. By the way, these are the same as the ones we just did. We just don't have diagrams. And in fact, I don't know if I would actually recommend drawing diagrams, to be honest. You could if you wanted to, but we know how to match up the parts just based on the statements. That's what I've been using this whole time. I didn't even really look too much at the diagrams on 6 and 7. So if we take a look here, what does DE match up with?
JK.
JK. All right, so DE is 18. JK is 7x minus 11. So 7x minus 11 equals 18. That'll be one of our equations. That's one of our equations, solving for x. Oh, wait, that's not right. I wrote JL, sorry. JK is 3y minus 21. 3y minus 21 equals 18. What else do we have? EF. What does EF match up with? EF matches with KL. Okay. Do you see anything with KL? Like up here? I don't see anything with KL either. What does DF match up with? JL. Do those match up? What's up? This one here? I wrote the wrong thing on the left. I accidentally wrote JLs instead of JKs. So I just scratched it out because I wrote the wrong thing. So EF matches with KL. EF is 23, but we don't have KL over here, so we can't write an equation for that because there's nothing to match up over here. However, DF from D to F matches from K to L. DF is here. Or sorry, J to L. DF matches with JL. DF and JL are both right here. So those are equal to each other. So let's set those equal to each other to solve for x. So 9x minus 23 equals 7x minus 11. So you can figure out what parts to match up based on what you're given. So we're not actually using this 23. The EF equals 23 didn't end up being useful, and that's okay, because we're still able to figure out everything we need with the other stuff. So let's add 21 to 18. What does that equal? 39. All right, so 3y equals 39. What's 39 divided by 3? 13. All right, so y equals 13. And all it says here is to find the values of x and y. So we don't need to plug them back in or anything like that. We're just solving for the variables. All right, for this next one, we have to move everything with a variable to one side. I'd suggest moving it to the left. So subtract 7x from both sides. And that would be 2x minus 23 equals negative 11. Make sure that minus stays with the 11. If you add 23 to both sides, what's negative 11 plus 23? 12. All right, so 2x equals 12. So what does x equal? 6. Divide by 2, x equals 6. All right. Try that last one on your own. This one's a mix of both sides and angles. See if you can figure that one out. if you'd like to see the equations, we don't need to use all of them. Some of the stuff there isn't needed. So like, here's my suggestion here. Look at the ones that have the X and the Y. So like right here, if you look at where X is, it's with MP, right? So that means that MP matches up with QS. So match MP equal to QS. That's this one here. Over here, the one with Y is measure of angle M. M matches with angle Q. Is there any information here about angle Q? No. Is there enough information to figure out how many degrees angle Q is? Yes. Which is why it's equal to that. Well, we have two of the other angles, right? Of a triangle. So the third angle would have to be what? Well, the three of them add up to 180, yeah. And if we have two of the three angles, how do we find the third one? We're going to use the information about angle S and angle R to figure out the measure of angle Q, which matches with angle M, so we can write our equation. What's up? 64. There are the last answers.